Hello, Big Elixir. I want to talk about playing with Elixir. I want to talk about telling stories. I want you to kind of settle in, get comfortable. I want you to get in touch with your inner 10-year-old. I want to engage with that kind of youthful, playful exploration side of us. And as Brian asked, there will be a little bit of golfing here, and that may excite or repel some of you, but I'm going to make it practical, so stick with me, and let's get started. We got the obligatory slide about me. You can reach me, G. Vaughn or Greg Vaughn. I love to talk to folks, so don't hesitate to reach out and tell me what I did wrong or even what I did great. I mean, either one, or what you thought about the food here. I love talking with folks, so don't hesitate to get in touch. I've been started with Elixir pretty early, doing it as a hobby. Been doing it professionally now for about 2.5 years at a small company called Seat Scouts. It's been a great tool for us, and we're really all in on Elixir. I should say we are hiring. We do have an opening for kind of a mid-level engineer. If someone's interested, come talk to me afterwards. I'm like being not so subliminally talking to that inner 10-year-old. How many of us have done this, right? I used to love doing this. I felt like, I was like the king of delivering macaroni and cheese to my mouth because I had it all on the tines of the fork and I had a mound on top of that. And this is the sort of playfulness, this sort of hacking, the old like MIT jargon file style of hacking where you kind of put something to a different purpose than what it was intended to. And that's what playing with Elixir, the type of playing that I'm talking about. And I want us to be that open-minded, that children naturally learn through play, and playing and exploration and experimentation all kind of overlap. They're all kind of the same thing. So I think we can become better Elixir programmers by approaching it with a sort of playful spirit. And 10-year-olds, they love bedtime stories. They love making up stories. And I contend that the code we write should be thought of, among other ways, as a story. It's what we're telling the other programmers, the other human programmers that read our code. The compiler's not so sensitive to the nuance as long as it's accurate. But if we can tell a story to the other programmers, it will help make your code more maintainable and help make it more flexible. And the better that we understand the language, which we can learn through playing and exploration, the more options we have in how we tell our story, the exact sentence structure that we use in those cases. I first learned to read English, kindergarten level, and there's a little book about this dog called Pug. And there were these two kids, Dick and Jane, that played with Pug, and it was just a really exciting book, It kind of starts out, see Pug. It's this whole page picture of the dog, and then turn the page, Pug runs. All right, that's cool, big picture. So you turn the page, and like climax of the chapter, Jane sees Pug run, right? It's really the basic stuff, but that's where we all start when we're learning either a programming language or a spoken language. And sometimes I think even the code we write when we're more experienced kind of reflects those simpler structures. And sometimes that's appropriate. If you were the one authoring this book, that would be exactly what you should use. But with more fluency, you can create sentences like, Jane laughs aloud as she watches Pug run laps around the yard, thankful to the veterinarian removed the cone of shame. So the core idea is still there, is that Jane sees Pug run. But you've added more nuance. You've added more motivation, more reaction. You're telling that story in a more complete way. And I want us to learn Elixir and the grammar of Elixir and learn enough vocabulary of our standard library functions to be able to build those types of sentences when that is the right level of abstraction that's needed in a certain context. And I'm really talking about writing our code in one function or a group of related functions. So what I kind of think of as like the low-level design. This is kind of like, how we're really structuring the individual components of the language. All the big stuff with processes, those are important too, but I'm not going to really be covering that sort of thing in this talk. So I want to start with this idea of let's taking apart Elixir a little bit here. Like it's almost like let's take off the screws on the back of the old radio or the old DVD player and kind of peek inside and see what's there, and then the hard part, getting it all back together and still works. Elixir has some lower levels that I'm not going to be discussing here, so I'm not calling this bitter Elixir. It's just semi-sweet. I've taken out most of the syntactic sugar. Let's let that soak in just a moment. It kind of hurts my eyes, all that visual noise, right? But I guarantee you give this to the compiler, and it says, "Thank you for accurate Elixir code. Have a nice day." At least that's what I think the compiler says when it says nothing. So, first level of syntactic sugar that we normally use is keyword lists, right? We use keyword lists all the time. It's a list of two-element tuples where the first element of each is an atom. And we use it a lot like maps, but the main difference is you can have the same key represented multiple times. And we have that syntactic sugar. You can get rid of the curly braces if you put the atom's colon kind of afterwards and you drop the comma between the key and value. In this case, do is our keyword, the key of the keyword list, and then we have a parenthetical expression as our value. We'll talk a little bit more about that part in a minute. So the old code and then the new, just to kind of compare. So now the last parameter of every function call. And when it's a keyword list, it doesn't need the square brackets, right? So now in two levels, we've gotten rid of curly brackets and we've gotten rid of square brackets. Now this brings in a point that the last parameter of a function call can do this. But we're calling def and def module. Those are functions. They're macros, but all macros are functions. The only real difference is that they're executed in a different context, but during the compiler's expansion phase. That's when they execute, but they're still Elixir functions. And so they're subject to the same syntactic rules. Next step. So now what we're looking at, uppercase bare words. The hello here. This is a module name. That's what we all expect it to be. But really behind the scenes, that's secret sauce for that colon, quote, Elixir dot hello. That's because Erlang modules typically start with lowercase, and we don't want to conflict with that. So we use uppercase and we put a prefix. So that makes interoperability with Erlang really great. And we get all this kind of normally in Elixir, but behind the scenes, there's more stuff going on. We also added in this step, optional parentheses for function calls. So, as I said, def and def module are function calls. So I've removed those optional parentheses. There's some people who have argued, oh, we don't want Elixir to have optional parentheses. Well, then you're going to have to write them around def and def module. So, otherwise you have to special case macros as special subtypes of macros as special subtypes of functions that are allowed to not use parentheses. And things get really complicated by asking for something that seems really simple on the surface. But when you understand kind of the behind-the-scenes piece of Elixir, you see where the complexity lies. But we have a formatter now that kind of takes care of that macro optional parens for us. And I've got one more step here. Yes. Do blocks, right? So we're used to using do and end, not necessarily do with an expression around or expression value. We don't have to put the in the top part. Those parentheses aren't actually necessary because there's only a single expression in there. And you've seen single line functions that use comma, do, colon, and that's the way we do those. But we can also do this lower form with do and end, so that we're really, which is again a special syntactic sugar, to not have to think about the keyword list that we're really passing into this macro function. And when we understand these levels of Elixir, it's going to allow us to kind of slice and dice it and approach things maybe in new ways and give us more flexibility in how we might communicate this solution to the same problem in different contexts. And so just, so there's before and after, just to kind of see the contrast here. There's like 4, or you could argue 5 or 6 levels, depending on how you want to count them, of syntactic sugar that we use every day. But finally, I've uncovered that, this clear Elixir code, and we know that this module's excited about beignets, right? We could figure that out before, but this is so much clearer. This is the happy code. This is the superficial Elixir or superficial Ruby-like syntax on top of Elixir is through these kind of simple syntactic sugars. But really, at the core of it, it's kind of closer to a Lisp. And that gives us some really nice power that we can use to explore the language. People who have explored macros understand this a good bit, but even if you're not going to write macros, understanding the layer of syntax will help us explore and play and push the boundaries with our Elixir. Every one of those steps compiles cleanly. I tested it all out. I'll share the slides afterwards if anyone wants to try it out. As I was doing that, here's something to offer as proof. I had an error message because I had it wrong at one point. And Elixir tells us great error messages. It tells us stories here. We usually gloss over them, but this one right here is making that last point I just made, that the do and end blocks, and in this case there's an else thrown in, it's really a keyword list passed to this if function. A macro type of function, but it really is just equivalent, and error messages tell us this. And this actually inspired me to push Elixir syntax in a little bit different direction, which I'll get to in a minute. So kind of remember this example, this slide. I'm going to get back to that. So when we're telling stories, we want to have that richness of vocabulary and grammar to know how to say something multiple ways. And this is how we pick the right Elixir code to write in a given circumstance. Sometimes you want to be very step-by-step explicit. Sometimes you really want to be very abstract. Sometimes you want to give lots of details and nuance, and sometimes it's just kind of, give me the facts. And being able to know multiple ways of solving a problem then lets you make that informed choice with the final Elixir code that you actually use. And I'm going to kind of go through a few different approaches to solve this problem. This is something very similar to something I've seen in production, where we have an invoice, and it has like these multiple line items, or called lines here, and those can be canceled or not, and then they have like a product attached to them, and there's actually a lot more fields on there, but those wouldn't fit on the slide, and not important. So one way of solving this is recursion. This is kind of like an all-purpose tool. We can always kind of iterate through lists with recursion. We could do, we're Elixirists, we love pipelines, right? We can pipeline this thing, right? Straightforward, boom, solve it. We could use a reduce while, be a little bit more efficient here. We could maybe expand our vocabulary a little bit. Maybe we know about enum.find and how this is almost like special purpose for this problem. Or its cousin, enum find value, is even like more special purpose and fits here. We could use a for comprehension. And this is not an exhaustive list, but this is just a few ways to solve one of these simple problems, and I want to talk about kind of how they communicate differently based upon which one we choose. So, recursion example. This is one way of solving it. It's kind of noisy. It's kind of low level. This to me is almost like explaining, Jane sees Pug run in a 3-beat gait with his right hind foot landing once and then 2 other feet and the last foot. And most of the time, the reader doesn't care about that level of detail of how Pug's running. But if that person is the veterinarian who just set the dog's leg, they probably are going to want to watch for that. So sometimes this is really the most appropriate way to write the code in a given context. I find this sort of direct recursion not usually the first thing I reach for, but after I've proven something else is a bottleneck. This is a great way to really eke out performance gains. Second way, filter pipeline, right? This is beautiful Elixir. This is like textbook, what we all learn from the beginning. And this is perfectly fine. This works great here. This is actually going to iterate the entire list of lines. We only have 2 here, so it's no really big deal. If you had a situation where you have like several thousand lines or hundreds of thousands of lines, this would be inefficient. So you probably want to look for some other solution that doesn't iterate the entire list to filter it before you just grab the first one, list first to grab the first one and ignore the rest. And so reduce while is a way of doing that. It allows us to control the iteration and decide whether to halt with a value or to continue the iteration. And this lets us handle those long lists effectively. Enum find is almost like purpose-made for this problem. Well, we provide a predicate function, and the first time that turns true, that element of the list gets returned. And so then, out of that element, we can do a map get and get our product out. Or we can use the little bit more precise find value, which is going to return the value of the predicate function. If the first time it's truthy, that's what gets returned instead of the actual element of the list. And remember that error message I mentioned a couple of slides ago? This is treating if as a function. We're using a function capture here, which was kind of the new idea that came to me. It's like, hey, if's a function. Let's see, can I capture it and pass that into find value? And it totally works. And I take advantage of the fact that there's a implied else block that returns nil. So if I don't match my condition, I'm going to get nil, and that's going to just keep iterating until it finds something that matches. So this to me is kind of like, a sophisticated way and kind of a very direct purpose way of solving this particular situation. And I would be remiss if I didn't include the for comprehension solution. This is the golfy solution here. This is the fewest number of characters. And one of the things that this does, I'm using the kernel.hd or head function. It needs to buy a vowel or two. And this gets us into the more ways you know how to express a solution to the same problem, the more nuance you can offer. If you pass an empty list to the head function, it's going to raise. It's going to say, there's no head element here. You're giving me a trick question. I'm not falling for it. The earlier solution that used list first, you give it an empty list, it says nil. No harm, no foul. And sometimes you would want nil there and just to continue on. Sometimes you want to say, no, I should never receive an invoice that has that doesn't have an uncanceled line. Or there must always be an uncanceled line in an invoice. And if it's not, it's an error I want to raise, let the supervisor handle it. So understanding these vocabulary parts of the language help us to even handle our error conditions better. And this is a perfect lead-in to, I love for comprehensions. I really do. And this whole talk is kind of an excuse for me to share my love of for comprehensions. They're so powerful, and I think a lot of people are scared of them, right? They seem complicated. And I want to try to clarify them. I want to share the love. I want some of you to come away from here kind of going, all right, I may try and use some of these sometimes. And I think most of us first experienced them in something like this. This is straight out of the Phoenix guides, right? In our view templates, this is what the examples show. This is how we iterate over things, right? This is basically equivalent to an enum map. And actually, not basically, it is completely equivalent to enum map. But this is what we see. People tend to like to call it for loops, which kind of makes me cringe a little bit because they can do so much more. For loops makes me think of flashbacks to C code and JavaScript and things like that. So I really try to say comprehensions all the time to help kind of make it clear that they can do so much more. So basic for comprehension, you've all seen, no big deal. This first thing we pass into it is known as a generator. It has to be the first parameter to it. And we're going to take each element out of that enumerable and call the do block on it, right? That's pretty clear, no big deal. But they can do more than that. Here, we have a for comprehension with two generators and a filter. Filter's the thing that I think a lot of folks haven't seen used, and it kind of makes it seem weird. But I want to walk through this and demystify it. It's really easy. It's a left to right sort of behavior. This is going to take the first value of x to be 1, first value of y to be 2. Going to check the filter. 1 is not 2. Great. So we're going to put 1 times 2 in our output. Then it's going to keep x at 1 and take the next value of y because it still has values to give. 1 and 3 are different values. 1 times 3 gets added to our output. Then we're out of y's. So x gets incremented to its next value of 2, and y starts over at 2. Well, guess what? Filter says, wait a minute, we don't want things where x and y are the same. So it just throws it away. Doesn't execute the do block. No harm, no foul. And we say, give us another value. So now we get x2, y of 3, and 6 goes in our output. That's really as complicated as for comprehensions are. You're allowed to have multiple of these generators and filters, and you can do some amazingly complex things pretty efficiently and declaratively. And I want to show a couple of examples of them kind of being put to use. So here's a sort of a mathematical thing. You want all, I think these are the permutations. I get permutations and combinations backwards. We want 1, 2, but we don't want 2, 1. We don't care which order each of the pairs are, but we want each pair of elements out of our list of 1 through 4. And so this for comprehension uses 2 generators from the same source list. And we use a filter. And we get exactly those pairs back. No muss, no fuss. But I want to kick it up a notch. There's a little monkey wrench in the plans here. What would we do if those list items weren't the same type? What if we had atom, float, integer, binary in there? Well, it's a trick question. It's the same code. Give us the right answer. This relies upon another little lesser-known feature of the beam is we have total term ordering. We can compare all these different types of things together. There's a defined order for this problem. The exact order doesn't matter. Just the fact that we can compare them in a stable, defined way still lets this simple less than operator filter things out perfectly. For comprehensions. I still love them. If there's one thing I love more than for comprehensions, it's pattern matching. But I can have them both at once. It's like cake and ice cream. So I've got nested keyword list here. And remember, we know that the keyword list syntactic sugar doesn't look like a 2-element pair, a 2-element tuple, but it really is. So we can walk over that and get that K and KW and pattern match on what we get out of our payment options. And then I can use another generator based on that in the inner keyword list. And this is looking for an active true. So as long as that appears in that keyword list, we're going to execute the do block. If it doesn't appear in that list, we throw it away and go start over at the next value that the generator gives. Now this plus that prior problem you could do with these nested maps, flat maps, filter, maybe throw a reduce in. There's other ways of solving it, but none are quite as elegant as a for comprehension, because this is kind of what these things were designed to do. And I don't have enough time to keep going on for comprehension. I could, but briefly mention there's more documentation. There's more things they can do. It slices, it dices, and it juliennes, right? You can look in the Elixir docs. It's in the kernel.specialforms module. For is not a macro. It's actually a special form. It's actually kind of a lower level, more primeval to the Elixir language. But it's documented really well in there. You can actually do your generators over binaries and bit strings and look at individual bits and bytes. You can send it into any collectible instead of a list. Most often used are maps. You could do it into a stream. You could implement collectible for your own special data structure when it makes sense, and use your for comprehension into those. You can tell it, I just want unique values out of it, so it will handle that sort of, put it into a map set and then turn it back into a list type of thing for you. And the latest feature, which I just saw Jose demo, last Christmas, or Advent of Code, he did some videos for, and showed this reduce option that lets you kind of treat the body as a reduce function, where you receive an accumulator you can pass back each time. It's not the first tool I use for that all the time, but if you really need to optimize and only iterate through a collection one time, this reduce option expands the situations where you can do that. So I told you, golfing. This is what inspired this whole talk. About 5 years ago, I think, there was a group that kind of started working some golfing challenges. The website's down here below, elixirgolf.com. It's still up. It's not active. We're not doing any sort of new challenges. It's been kind of sitting there for a while. But this was the first thing I did. I had some spare time. I wasn't working in Elixir yet. So this was the way I kind of, testing out my chops and kind of, playing with things. And small problems I can kind of get in and out of pretty easily. So it was really great for learning things. And this kind of harkened back to, I think it was probably, 10-year-old me, right? Your inner 10-year-olds are still listening, right? 10-year-old me first learned about the Caesar cipher from some cartoon or something. And I thought it was, just brilliant. And so now I kind of get to implement this in code. For anyone not familiar, it's just a real simple coding where you just kind of pass your ciphertext just a fixed number of letters later in the alphabet, right? So A could become C if your offset is 2, for example. So I went through this and I learned how to say the same code multiple ways, right? Now the context of doing golfing exercises is you've got someone with a really short attention span, and your reader of your code can only handle the fewest characters possible, right? This is not production code. This is not about making it easy for people to read. It's just for someone who just has a very small buffer size in their brain, right? So this was my first solution to the problem, or this is very close to my first solution. What I actually wrote first doesn't compile anymore. Use some now deprecated features. But this is, in the spirit of what I had done originally. And I thought, I'm being nice and golfy here, right? Like I'm importing stream, so I don't have to type stream everywhere. And look, using a single letter variables, isn't that, that's just being really obscure. And oh, and look, I'm not even line breaking on my pipeline, right? Yeah. I did know about map join. That's another sort of vocabulary thing that not everyone knows, where you can map over a enumerable and join it together all in one. So that kind of saves you characters, not having to call multiple functions. I learned a little bit of IO puts and IO gets. That's kind of the way the problem was stated. We have to actually get the input. I I didn't have to put that prompt in there into your code here, but this is the first example I did. I learned later, and I take the prompt out and save some characters. Using apply to the module and the function name lets me lets me pass the string split as a string split. Is going to take your input of n, your offset, comma, your ciphertext. It splits it into two variables, two parameters that get passed in by the apply without having to deconstruct those. That was a little thing I did, trying to save characters. Well, I was so far off, this was nowhere close to solving the problem. Kept working on it, kept playing with it, iterating in my spare time. There were a few steps in between. And this is kind of an intermediate step here that I'd reached. And this taught me some other sorts of things. In the first one, what I had done, I forgot to mention this, I created a map that has the character-to-character mappings. And then I just looked it up for each character that was input. In the second one, I created that with a for comprehension. I thought I was being really clever. And I'm using into here, and that's what's actually creating that map that I can look up those character-to-character mappings. But you know what? Assigning that to a variable, those are wasted characters. I can just recompute it for each character in my input list. Performance doesn't matter in golfing. You throw those things away if you can save characters. It's wasteful to recalculate the whole list, but that's not one of the parameters of the problem. And this also, I realized, hey, def module, this is like so many characters. I don't need this in my life. I can apply to an anonymous function and get the same sort of behavior going on there. Still doing the map join the same way, code points. I'm not creating that lookup module attribute A anymore because I'm doing a little bit of ASCII math. Number 97 in there, that's ASCII character for A. So I'm doing ASCII math, and I'm using rem, remainder, to do the modulo 26 math, so it kind of wraps around properly. So I thought I was getting pretty good there. Then we started having some guys people working the problem that got them down to tweet sized. 5 years ago, tweets were 140 characters, not the voluminous 280 we have today. And so getting this down tweet size, it kind of became like a collaborative game at that point. We weren't competing against each other, but we were kind of sharing. I was reading other people's Golfi code and making sense of it. And I learned other techniques by examining that. And I was deep in the problem, so it wasn't like a real hard thing to get into because I was familiar with it. And then some of us collaborated and finally got down to kind of basically the winning solution. It was pieces from multiple people. This below, in all of its glory, is a Caesar cipher solution. I want to talk a little bit about the differences from before and after. The big thing is the binary comprehension. We're using a binary generator to read each byte out of that string that was passed in. We don't have to use that really verbose string.codePoints function name anymore. Got rid of all that. Save those characters. Of course, you're seeing there's optional parentheses where there's spaces taken away where they're not needed. I'm not going to spend any time with the situations when those things are possible or not. But it was pretty impressive, kind of getting this stuff down to under 100 or under tweet size. There is one variation. If your offset is no more than a one-digit integer, like 0 to 9, there was actually an Erlang function that could read from I/O and use fewer characters. So we could get down under 100, but that wasn't one of the parameters of the problem. But that was the other thing that this did. This has got me digging into some Erlang documentation. That's part of our vocabulary. That's in the standard library. It's right there in the Elixir code at runtime, and it doesn't cost you anything to kind of bring in a hex library or nothing. You just use the standard stuff that's there, and we had some fun. And I would encourage some of you, any of you, all of you, to go look at elixirgolf.com. It's not active now, but there's I forget, 4 or 5 problems there. The host of the site did a great job really explaining the solutions. So you can take a problem and spend some time on it, play with it. You get stuck, you can kind of go and learn from what's already happened. So, all right. So now I go into the part of the talk that's kind of some of the things that I've learned from taking this playful mindset and pushing Elixir, like Play-Doh in my hands. And you just kind of play with it. Is it supposed to go this way? I don't know, but I can make it. And maybe that's a good thing, and maybe that's a bad thing. We're probably all familiar with width. It's a great feature. But let me set the stage for this example problem. This is just a made-up example, just to show what I'm talking about. Map fetch returns either OK value or the single atom error, and maybe your code expects a 2-element tuple as a result, so you want to have error key not found, right? It's real simple to wrap it and make that happen. Or you can do it in a one-liner. With statements, or expressions, I should say, with expressions are similar to for, and I think a lot of people use them and maybe don't fully understand how they operate. What this is going to do is it's going to do a map fetch, and if the result matches, pattern matches the error, it's going to execute the do block. If it doesn't match the error, it's going to return the value of map fetch to the else block, and the default else block just returns what it receives. So if you get OK value out of your map fetch, it just kind of else block just kind of passes it along. This I wouldn't use in this particular example in practice, but what this is really good for is, suppose you've got some value that you have multiple ways of looking up, and you kind of want to have fallbacks. So maybe you check to see, do I have it in my gen server state, in a real close cache? If I don't have it there, I want to go kind of look it up in an ETS table. Or if I don't have it there, I'm going to have to actually call into Postgres and do some calculation to get this value. But the first one that matches, you kind of want to exit, right? And you can write this with a bunch of nested ifs or cases or cons or whatever you like. But with the with statement, you can have each of those in there matching the error condition. So it's only on error will it continue and try the next one. And when it succeeds, the else block passes it out. So it's kind of like inverting a with statement so that the happy path is the else part of it. I think there's also some like expansion vocabulary. There's, this one. Map new to has a serious case of fear of missing out, right? People love writing, taking some enumerable into an enum map to transform it, and then they pass that enum into an empty map. Well, there's a function, map new, custom made for that. You take your input data, a transformation function, and it gives you a new map. And it tells you, map new, this is what I'm doing. You're really revealing your intention here. And so I see a lot of code like the former, and I really think the latter is not just shorter, but more intention revealing. Another thing people, I don't think, explore enough is get in. Let me set the stage here. You're kind of wanting to look up in this nested data structure and, hey, if this value's not here, I want an empty list back. Otherwise, give me the real value that I'm expecting, right? We've all done this. It's a very sort of almost imperative, step-by-step, this is what I want to happen. And sometimes that's what you want. You could do something like this. Knowing that map get has a third default parameter, and kind of give it a default that's kind of all set up so that transactions key is there, and you'll get an empty list. But even this, you're kind of duplicating transactions here. You can use get in. Get in and its cousins, put in, pop in, update in, are all really powerful tools for accessing data in these nested structures. And it takes a list of sort of steps to iterate into that structure. And if any one of those returns back nil, it just stops. So you're not having to test for existence at each kind of level as you nest. This will just return back nil as soon as any one of those pieces returns nil. So in this case, we do an or empty list. So we're going to make sure we're not passing nils around our program. And this also has some really fancy advanced things you can do where you can actually pass in functions instead of just sort of values and keys to iterate in. And you can also look at particular elements out of a list or at all the elements of a list. So there's some pretty powerful things you can do. So I encourage you to kind of play with some of this stuff, look at the documentation. It's in kernel, so this helps you know when to write your code in a given circumstance where this is the right thing to fit. And map put new. This is almost like the inverse of that last problem where you actually look to see if that key is empty in the map, and if it is, you're going to stick an empty list in there so that later code doesn't have to do the previous slide's logic. And this is fine. There's a standard library function custom made for this. Put new. I'm not sure. This is very well known. What this says is if this is a new key, put it. If it's not a new key, ignore it. So I think, yes. All right. I'm stopping there. I want to encourage you to play with your food. Get macaroni and cheese. Get that Elixir. Squeeze it. Put it on your forks. See what happens. Squeeze it, the Play-Doh in your hands. Play with it. Explore. Have some fun. Do some golfing exercises. Do some exorcism or some Project Euler or play with these things and find your way around, especially enumerables and iterating lists and plucking values out of things. You'll use it all the time in your production code. And knowing multiple ways to approach a problem will make you better at telling your story, at telling that story to the future programmer. And in a few months, you're going to forget your story, and it'll be all new to you. So it will be helpful even to yourself or to your teammates or to open source. It could be anyone in the world that you're explaining yourself and telling them the story of your code. So thank you. That's all I got. And I'm open for questions.
Thanks, Greg. I think we have time for one question if there's one. Okay, thanks, Greg.
I'll be happy hour tonight. Happy to talk to anyone. Thanks.